were coming in for the sonograms and blood tests. And many of you have met Dr. Josh Klein, who's going to be running our office in Brooklyn that will be opening this summer in August, which will be a much more convenient location for having reproductive monitoring, although the laboratory is in Manhattan, on Madison Avenue. So I wanted to talk about the embryos, the genes. What are genetics? Why is genetics so important to an embryo? Well, I like to give the analogy that if you bought a computer and the computer did not have a disk to put into the computer wouldn't work. You have to buy a software program to put into the computer. Well, the genetics is the same thing. The baby is the analogy of the computer here, and the genetics is what controls the development of the baby, so the baby should become a living being. Inside each of us are billions and billions of cells, and in the center of the cell is a nucleus. And the nucleus is the DNA that controls the development of the cell, which controls the development of the embryo. There are about 40,000 active genes that control the development of a person. Something can go wrong in any of the 40,000, but it's much more complicated than that, because of the 40,000 known genes, they interact with each other, and each gene could be multiple genes, because one gene talks to a different gene. And these genetics are what controls how an embryo develops. Where are the genes? How big is this? Well, for those of you, again, who don't have a biology background, we know we're made of something called DNA. All of the information that controls whether an embryo develops into a healthy person or not is controlled by the DNA, which is controlled by these 4 messages, these 4 computer codes inside every cell. And it's the order in which these 4 molecules, adenine, thymine, guanine, and cytosine, mix together that creates the alphabet that creates a person. These genes are organized in a little ladder called a helix. Each one of these molecules that comes together, 3 of them together, control the alphabet of what's going to become the person. These genes are wound up. If you took a string of genes and you wound them and wound them and wound them and wound them and kept winding and winding and winding, you would wind them down to what's called a chromosome. That we have 23 pairs of these chromosomes. How long is a chromosome? Well, there are 3 billion molecules of DNA on each one of the chromosomes, and we have 23 of them. There are 3 billion, altogether in the entire DNA, in all the 23 pairs of chromosomes, or 46 chromosomes. If you took the chromosome and unwound them and stood the string in one cell, it would be as tall as you are. So all of us have the DNA that is about 5 to 6 feet tall in each of our cells. That's how long the message is. And that message has to be perfectly organized to develop into a human being. If anything goes wrong with that message, the embryo will fail to grow, or the embryo might become a child with a handicap. So the very basic thing is the structure of these chromosomes. As I mentioned, there are 23 pairs. They're numbered from longest to shortest, number 1, 2, 3, 4, 5. Each one of these has millions and millions and millions of DNA molecules in them. If you have 2 chromosomes that we call X, that makes you a female. And if you have 1 X and 1 Y, that's a male. Some conditions, there could be a mixture of that. You could have 2 X's and 1 Y. That's abnormal. That's 47 chromosomes. In that condition, we call Klinefelter syndrome. Many men are afflicted with Klinefelter syndrome who have very, very poor sperm production. They may, in fact, have no sperm. 60% have no sperm at all. About 40% of men with Klinefelters will have an occasional sperm that can be retrieved by testicular failure. And this is purely a chromosomal problem that results in a health problem. But this chromosome, chromosome number 1, is a very big one. If there's something wrong with chromosome 1, the baby cannot develop. That chromosome has to be perfect, or the embryo will fail to develop. So chromosomal testing is very important for healthy embryo development. So the DNA, gets into the cell through the sperm. Each of the sperm has half of the chromosomes. 23 are in the sperm, 23 are in the egg. The sperm enters inside the egg, either naturally or through ICSI. And then we see signs of a female and a male nucleus. This is a fertilized egg, which has 2 nuclei in it, a male and a female nucleus. And this one develops into a beautiful 8-cell embryo. If you grow it a little bit further, it'll develop into a blastocyst. This is a day 5 embryo, and a blastocyst is right at the stage that an embryo develops where it implants into the uterus. So you can see why the DNA can cause the embryo to fail to get to this stage, and it won't implant into the uterus. Now, if you look at a blastocyst very closely, you see a ball with a ball inside it. The ball inside it is actually the fetus. The outer ball forms the placenta. So this little ball inside this bigger ball is actually a very tiny, tiny, tiny baby that's going to develop. And this is that baby, if you looked at it at about 2 weeks after it's implanted into the uterus, it doesn't look anything like a baby, but you can see one side is bigger, one side is smaller, this side will become the head, this will become the spine. And from this, because of the way the DNA organizes the information, a living human being will form. And around 8 weeks, it starts to look like a baby. By 8 weeks of development, 6 weeks after ovulation, 5 weeks after we replace the embryo into the uterus, this is what it looks like. You can really see that how the miracle of life is formed. And this is all controlled by the DNA. Those 3 billion molecules that each cell has work together in synchrony, a true miracle of life to create a person. Now, many people say, well, genetics, I've done genetics. When I was in high school, they took us to Doria Shurim, we all had blood done. I know my genetics are normal. I have to commend Doria Shurim for the amazing job. There's no community in the world like the Frum Jewish community that has done an amazing job to wipe out the risk of genetic diseases. But Doria Shurim did not finish the job. They did the best they could, up to the point that you were tested. The problem is you were married 10 years after you had the high school testing done. Genetics has learned new things in those 10 years. Current state of the art is for an Ashkenazi couple to have 20 different things done. Now remember, I said there are 40,000 known genes, and we're able to check 20 of them. If you went to Doria Shurim 15 years ago, maybe they only did 10 different genetic tests. So you're missing some genetic tests. Well, is it important? We're already married. What can we do? If our genes aren't compatible, we have to have the child. Is it important? The answer is, of course it's important. As you heard, we can do genetic testing on embryos. So we can pick normal embryos. So if you've been to Doria Shurim quite a while ago, it is important to get an update. And the doctor wants you to get new tests so we can tell if your genes are normal or not. What's new is that there's a new test that just became available, just became licensed in New York State last month, which now brings it from 20 up to 100 different tests. And you don't read the list, but I want you to see how big the list of different genetic disorders that we currently can test you for, and maybe Doria Shurim did about 5 or 10 of them. The name of the test is called Counsel. It just got licensed in New York State last month. And I am recommending that everybody who's been to Doria Shurim should get this testing done. If anybody's interested in knowing more about Counsel, it's spelled there, C-O-U-N-S-Y-L. They have a beautiful website. You can look them up on the internet, learn more. We are going to start using this as soon as we work out some of the details that we need to make sure that we get good reporting out. And we're going to learn about new genetic disorders. Now, the thing about this testing is all of us have something. And about 1 to 2% of couples that we're going to test for all of these new tests will have something. So genetic counseling is very important to see which of these tests are serious, which of them are not serious, which of them will require genetic diagnosis of your embryos to prevent disease. Now, none of these are trivial diseases. We're not testing for your hair color or eye color. These are all serious medical problems, some of them more serious than others. So when you get this new testing, you'll be hearing more about this. It's called Counsel Genetic Testing, and there are other companies besides Counsel that will be coming on the licensing of new genetic tests very, very shortly. So this is brand new. Only got licensed last month, Counsel Genetic Testing. Now here's a case, not a religious couple, but here's an example of what I was talking about. This woman, this is an article from May 14th, New York Times. This woman got pregnant with sperm that was frozen for 20 years. Sperm can be frozen a very, very long time. She heard that the father of the child was tested for cystic fibrosis, and the truth is he was. He was tested for cystic fibrosis 20 years ago, according to the state-of-the-art of cystic fibrosis testing 20 years ago. Well, we learned more about this disease. Cystic fibrosis causes lung problems, the babies have trouble breathing, and this baby was unfortunately afflicted with cystic fibrosis because they assumed that the testing from 20 years ago was current to today. So I am recommending that if the testing was done a while ago, we've learned a lot about new genetic tests. We're getting much better at picking up disease, and I do recommend that everybody get new genetic testing done. To Doria Sherman's credit, though, by the way, if you don't want to do it with the doctor, you can go back there and say, I want to get my updates done. And they will do that. They will say, okay, you were tested, I see, in 1995, so we're going to test you for the things we're currently testing now. There are about 100 known genetic mutations for cystic fibrosis. 20 years ago, they only tested 20 of the known 100, so that's why that baby, unfortunately, had the disease. So that's a baby born with a disease, but mostly people are not coming to me because they have a baby afflicted with a problem. They're coming because they're not getting pregnant, because their embryos are dying. They might be miscarrying. Chromosomal abnormalities are usually not going to result in a baby with a birth defect. Typically, they're going to cause the embryo to die, and the embryo will miscarry rather than causing a physical problem. So we already talked about Klinefelter syndrome, where you have two X's and a Y. Well, this one is Down syndrome. This is a baby that has 3 copies of chromosome 21. This is more common in older families. Many times you'll see a family with 14, 15 kids, and the youngest one came when the mother was over 43 or 44 years of age and has the Down syndrome. You know, it's very obvious when a child is afflicted with Down syndrome. They're wonderful children, but they are mentally slow and have all sorts of health problems. And this is due completely to an extra copy of chromosome 21. So this is something we can test for. A religious couple probably could not get this tested for when they're already pregnant, because the authorities will not allow a termination of a pregnancy at the point that we can test during pregnancy. But there's a couple of new things that are coming out, which is the testing for Down syndrome in the mother's blood at a very early stage. It's not early enough yet that it can be used to allow a termination of pregnancy before the Talmudic prohibition against terminating a pregnancy, but it will get earlier and earlier. But currently, today, I can test your embryo for Down syndrome by doing pre-implantation genetic testing, and most rabbinic authorities do permit testing of embryos and only putting normal embryos back in. This is called a structural chromosomal problem. Some families, however, have unique problems that only occur in their family. For example, there could be some kind of spinal disease that doesn't even have a name that many of the cousins in this family have. These are called single gene disorders, and we can test for that too. We can test the embryo. So if you and your cousins all are afflicted with a certain serious medical illness, even if the disease does not have a name, if it's an inherited medical illness, the embryo can be tested to eliminate that disease. Now, here's an example of how complicated these genes are. These 5 genes all cause cancers. Many of you have heard about the BRCA2 gene, which causes ovary and breast cancer. Unfortunately, this is an Ashkenazi popular disease, more popular in Ashkenazi families than not. But this BRCA2 gene also causes prostate cancer and is associated with pancreatic cancer. And this gene is associated with different cancers too. And these genes cause rheumatoid arthritis, and some of them cause you to have early heart attacks. So we're learning much, much more about these genes, and the efficiency of testing embryos, I think in the future, we're not ready yet, in the future, these genes will also be tested for in the embryos, so we can eliminate diseases in embryos. Now, currently, embryo testing is also being used to improve the chance of a single embryo being successful. Dr. Scott spoke to you about the fact that we should really not be putting in high numbers of embryos, and that's a big change in IVF. In the beginning of IVF, we were putting in 4 or 5 embryos because we knew it was very rare for the embryos to implant, but currently we're going down to 1 and 2 embryos. And the reason we can do that is we can know more about the embryos and what they look like. Looking at the embryo doesn't help us. Embryos that are pre-screened for genetic disorders and chromosomal abnormalities have a much higher chance of producing a pregnancy. So this is a newer thing in IVF, and many of you who are being faced with IVF are being advised that maybe you'd like to have your embryo screened for chromosomal normalcy before the embryo goes back in. I think the cost and the concerns about The efficiency of genetic diagnosis means that it should not be done on every single case. If there is a high risk that your embryos are going to be abnormal, it definitely should be done. But it does add a lot of cost and complexity to IVF. So I'm not at the point now where I recommend to every IVF person to put in embryos that have been pre-screened genetically. However, if you want only one embryo to go back in, having your embryos pre-screened definitely will improve the options. So it is something that it's evolving. You'll hear much, much more about this. Some centers are doing this now routinely on every patient. Some centers do it on some patients. I like to be in the middle. I like to not do everything for everybody. I like to use my best judgment to decide, but this is something that's very, very new. So the way the embryos are biopsied are with a machine called a micromanipulator. This is basically a microscope that our technician can go into the embryo and pull out a cell of the embryo. And in the micromanipulator is a little laser, and this laser actually uses light waves to take a little piece of the embryo off. So this is the way these embryos are currently being biopsied. Now, the hour is late, so I don't want to spend a lot of the time on this, but this is the way it was done. This is why you have to come to these conferences and stay current. Prior to about 5 years ago, this is the way embryo biopsy was done. An embryo on the 3rd day of development would have one cell removed from it by making a hole in the embryo. That cell was put on a dish. The dish was marked with the big circle, and we would send that cell off to a laboratory, and they would paint the chromosomes on it. And if there were 2 copies of the red chromosome, you'd see here that's normal. If there are 3 copies of the red chromosome, that's abnormal. And this was done for about 15 years, and this was called FISH. I only show this to you to show you how much fertility has changed. We no longer do this. We do not recommend FISH except in very few circumstances where it's the only tool available. This is one of those things that was so new and exciting 15 years ago, and it has completely been abandoned by all genetic centers that do reproductive medicine now because it just does not work. The current state of the art is to biopsy the embryo 2 days later on the 5th day and to get a complete chromosome number. You need the laser to do the biopsy. So remember I showed you on the 3rd day. This is the cell being removed on the 3rd day, but now we're doing the biopsy on the 5th day. This is a 5th day biopsy where the cells are much more advanced. This is the part of the embryo that forms the baby. This is what's called the trophectoderm that forms the placenta. And this is not as important to the embryo. And more importantly, we're getting a few cells out of the embryo, not just one cell. And that's one of the reasons this test is so much better than it used to be before. So the jargon that you'll hear right now if you're doing embryo testing is CGH or RPCR. RPCR is the laboratory that Dr. Scott and Dr. Nathan Treff are currently using. We can get the results back in 12 hours, which is super important. We can't keep the embryo alive for much longer than that after we do the biopsy on the 5th day. So we have to get the results overnight. We biopsy in the afternoon of the 5th day. We get the results back in the next morning because the laboratory is running all night long. While you're sleeping, they're working. And in the morning of the 6th day, we do the transfer. And we still have, however, the need for something called PCR for single gene disorder, a little bit complex, so we won't go into that now. Sometimes the results require the embryos to be frozen because we can't get them back fast enough. And this is another thing that's changed enormously in the last 2 years. This change is probably one of the biggest changes that we've had in the last 2 years. And we went from 50% of the embryo surviving freezing to 90% of the embryo surviving freezing due to this term called vitrification. Now, if you look at these 2 drops of embryo fluid, this one looks like a snowball, and this one looks like glass. The snowball is what it looks like when you don't do vitrification, and this is the fluid with a special cryoprotectant in it that looks like glass. Vitreous in Latin means glass, so it forms a glass-like state. And this newer technique results in an incredible improvement in the embryo surviving so that we can store the embryos and keep them for you for much longer. So this is the older machine. Basically, you put the embryos into the machine, you go get a cup of coffee, come back an hour later, and the machine would ring like a microwave oven and say, embryos are ready, you can put them into the tank. And it was very convenient, very easy for us, not a very good technique. We took our planar freezer, we put in the closet. It's a very nice paperweight right now. Currently, it's a laboratory-intensive, technician-dependent technique called vitrification. There's no machine anymore. We got rid of the machine. Now it's a labor-intensive thing. The technician has to actually work with themselves to make the solutions perfect so that the embryo can be very quickly frozen in this glass-like state. And you can tell, I had a transfer I did the other day where the embryologist had 2 pictures on the table of thawed embryos that I was going to be putting in. One was from 5 years ago, one was from 3 months ago. And I said, that's the one that's slow freeze and that's the one that's vitrification. They said, I don't know, let me look. They said, yep, you're right, that was it. Because you can tell to look at the embryo. The slow freeze embryos don't look as beautiful when they come out of the freezer. So this is something newer. If your embryos were frozen 10 years ago, you have no choice. They were frozen by slow freeze. But all new IVF centers should be doing vitrification. It's the only kind of freezing we're currently doing. What about, I'm almost at the end, but I wanted to just briefly talk about age and some stuff that's happening in the future. We talked about what's happening now. We talked about PGD. We talked about vitrification. We talked about gene disorder. This is stuff that's going to be in the future. This is the stuff I was referring to, probably not in your reproductive lifetime, but you will all have boys and girls. And in your daughter's reproductive lifetime, I'm sure that these new techniques will be available. So we know that as you get older, you've lost a lot of eggs. So you see how the eggs just die off as we get older. When you reach 50, you're in menopause, you have no eggs left. Very closely following the fertility curve. This is the IVF success rate for the United States. You can see it at 42-year-old women, it's about a 15%, 45-year-old woman, about a 5% chance of being pregnant with IVF. Very, very, very bad. And the reason is because we've lost all our eggs. So what's around the corner? This is a scientist at Massachusetts General Hospital that claims that it's not true that when you lose your eggs, you've lost them for good, that the ovary can regenerate eggs. I'm very closely watching this research. Hopefully, when I speak to you at the next Daytime Conference, I can give you updates as to whether this is true. Please don't wait for this. Anybody who is now 19 years of age will probably not have this technique available to them. But I'm sure you'll all have children, and hopefully in your daughter's lifetime, when she turns 45 and is running out of eggs, scientists will be able to grow new eggs for her from these stem cells. So this is really hot new. I show this to you to tell you it's not ready yet. So anybody that's in menopause who asks me, can you put these new cells into my ovary and create eggs? Not now. I'm guessing not for 10 years, probably not for 20 years, but maybe in the future. So we'll keep an eye on this one. And the last thing, very similarly, is male factor fertility. Male factor fertility is often due, sometimes due, I would say, due to genetic problems in the Y chromosome. We know that if you have a gene missing, we talked about genes and disorder. Here's a gene that causes infertility. If this gene is missing, not a single man has ever had a baby, ever, with this gene missing. He never has had sperm. He has to adopt. There's no other choice for him. If this gene is missing, however, some men do have some sperm. And the urologists like Dr. Barhama, Dr. Katlowitz, Dr. Goldstein can go into the testes and remove testicular tissue and get sperm. So it's very important to know which genetic defect is causing this problem. Now, this is not the majority of male factor. This is a small piece of male factor. We're talking about the future. So why is this important? Because scientists in Japan have actually used adult cells to make baby mice, to make sperm in baby mice. This has happened in the laboratory in mice. What they took is they took cells from an adult man and they reprogrammed the DNA in the adult man to create, in the adult mouse, to create a mouse sperm. And these little mouse puppies were born through this technique. Now, I think rightfully so, our federal regulators are very careful about this kind of reproductive research in humans. We want to make babies for everybody. And if you have that deletion that does not allow your testes to form sperm, we know that you'll never have a baby. But it's going to be a bit of a jump before we're going to take this mouse research and start doing it in humans. Again, probably not in your lifetime, but in your son's lifetimes, we will see this research probably panning out because they've already done it in the laboratory. The Food and Drug Administration here, Europe and Israel is even more strict, by the way. Even China is more strict than here about doing research on human embryos, is not going to allow us to just say, we want to do this research, is it okay? No, they're going to watch it very, very closely. The Food and Drug Administration is more interested in protecting our safety than in advancing science. And to their credit, they prevented lots of diseases from bad drugs in the United States that have caused diseases around the world. So I do applaud them. And I want you to know about it. I don't want you to wait for it. I have had people ask me, I have AZF deletion, DAS deletion. I know I don't have sperm. Can you freeze my wife's eggs? She's 25 now. Maybe when she's 40, you can make sperm for me. I wouldn't want you to spend the money on freezing eggs yet. I think we're too far off from that. Hopefully in the next 5 years, I'll change my tune and say we're right around the corner. But this is a hot area that people are studying. No sperm, can we make sperm out of human cells? So hopefully in the future. So I want everybody to keep up to date, to know which treatments are good, to know the risks and the costs of why the treatments are being offered you. Find a guide that you trust. Find a doctor that you trust, an organization like ATIME, to help guide you when you hear all this stuff, to know if it's real or if it's something that is not going to work out. And learn from our culture, from our literature. You learn from every man, and then you'll be able to make wise decisions in your reproductive care. Thank you very much for allowing me to speak.
Thank you, Dr. Grunfeld. As always, very precise, very direct. His information that we know our tefillas can bring the doctors to understand things much quicker, so we just have to daven that the doctors open up the eyes of the doctors. They should be able to treat us and help us in the way that we need to be helped. On that note, I just want to call up Rabbi Weiss. It's a pleasure for me to call him up. I just want to say one word. Rabbi Weiss, I don't know if anyone knows, but I've read any paper over the last 2 weeks knows he runs the Moisad Chish, the Sasapia, and they had a breakfast this morning. Over the last 2 weeks, I don't think went by a day that he didn't call me where things are up to, what's needed, how can he help out. And he's always available for the time in every single way, and I think it's appropriate that it comes out in Parshas Bahaloisku. And we say, Bahaloisku is a night, it says Rasha, the Hag Shuvah Shalahav, Shalai Shimon. I think we say the same thing, the Hag Shuvah Shalahav, Naftulah, Shalai Shimon. He's always available, always does it at the utmost, and I think Naftulah is Gematria Yahad. I'll leave that for Rabbi Weiss to figure out. And that I'd like to call up Rabbi Weiss to give the closing remarks. Thank you so much.
The mother of the Chedisha Harim was once walking in the street with wood on her shoulders. Her son, the brother of the Chedisha Harim, who was a very rich man, sees his mother walking in the streets with planks of wood on her shoulders, runs over to her and says, "Ma,